Hi all, I'm Aswathi Krishna, Assistant Professor, Department of EEE, Vedavyasa Institute of Technology. Here I'm presenting a tech talk on Smart Grid, the future grid. Transforming the traditional grid including differences with traditional grid, components, advantages, disadvantages, smart grid architecture, communication, components of smart grid, and the applications. What is electrical grid? That means interconnecting networks connecting the generating stations to the end users via transmission and distribution system. And energy generation is done in a centralized power plants only. Energy distribution is in one directional. That means from power plants to the consumers, monitoring and restoration of grid is done manually only. And moreover, it is a unidirectional communication. When it comes to smart grid, all over the world, electric power systems are encountering radical change stimulated by the urgent need to decarbonize electricity supply, to swap aging resources, and to make effective applications of swiftly evolving informations and communication technology. All of these goals converge towards one direction, that is, smart grid. Smart grid can be described as the transparent, seamless, and instantaneous two-way delivery and energy information, enabling the electrical industry to better manage energy delivery. And smart grid can also be named as electricity with the brain, the energy internet, the electronet. According to the definition given by NIST, smart grid is a modernized grid that enables bidirectional flows of energy and uses two-way communication and control capabilities that will lead to an array of new functionalities and applications. Main comparison between the traditional grid, that means the existing grid, and the smart grid. Existing grid is mostly electromechanical in nature and smart grid is digital in nature. Our traditional grid is one-way communication and smart grid is two-way communication. And this is mostly centralized generation and distributed generation is smart grid. In existing case, few sensors are only used and case of smart grid, sensors are used throughout. And the case of the existing grid, manual monitoring is only possible and the case of smart grid, digital self-monitoring is possible. Failures and blackouts are possible in the case of existing grid. But in the case of smart grid, no blackouts will be there. And the main benefits of smart grid: more efficient transmission of electricity, quicker restoration of electricity after power disturbances, reduced operation and management costs for utilities, and ultimately power costs for consumers. Increased integration of large-scale renewable energy systems too, and improved security. And according to consumers, there are more benefits. Updated information on their energy usage in real time. Program the smart devices to run during peak off hours to lower energy bills. And it comes to the architecture and smart grid communication. The main components of smart grid communication are smart home appliances, smart meters, gateways, data aggregator units, and meter data management. And the different networks are associated with this smart grid communications. They are home area network. It extends communication to endpoints within the end user home or business, that is HAM. And comes to neighborhood area networks, that is NAN. It manages all informations between wide area network and the home area network using medium voltage lines. And comes to wide area network, WAN. It covers long haul distance from the command center to local neighborhoods downstream and the other sensors and actuators. And comes to the components of smart grid, smart home, renewable energy, operation centers, distribution intelligence, and plug-in electric vehicles. What's smart home? Smart home depends on many things: smart meters and home energy management systems, smart appliances, home power generations. And comes to smart meters, it provides smart grid interface between consumer and the provider. And it can operate digitally, allow for automated and complex transfers of information between consumer end and energy service provider. And also it helps to reduce energy cost of the consumers, provides information about usage of electricity, in different service areas to the energy service providers. In case of plug-in electric vehicles, smart grid have the infrastructure needed to enable the efficient use of plug-in electrical vehicles. Using plug-in electrical vehicles, we can reduce the dependency on oil and no pollution while running on electricity. In case of plug-in electric vehicles, rely on power plants to charge their batteries. Plug-in electric vehicles get incentives from energy service providers for providing energy to the grid through this charging. Energy service providers encourages the consumers to charge batteries of plug-in electric vehicles in off-peak hours. Plug-in electric vehicles also can be used as an energy source in on-peak hours. When it comes to operation center, first of all, we can look at the drawbacks of traditional operation centers. It tries to make sure the amount of generated energy is getting used. If the grid voltage drops due to excess energy generation, the grid becomes unstable, no means to detect oscillation which leads to blackout, and limited information about the energy flow through the grid. And comes to smart grid, for monitoring and controlling on the transmission system in smart grid phase a measurement unit is used, that is PMU. PMU samples the voltage and current with a fixed sample rate. By increasing the sampling rate, PMU provides a dynamic scenario of the distribution system. Multiple PMUs form a phasor network. Collected information by the phasor network is analyzed by SCADA system. And this is a distribution intelligence system. And we can see the traditional grid during blackout and smart grid during blackout. And comes to advantages and disadvantages of smart grid. In the case of advantages, better energy management system, proactive management of electrical network during emergency situations, better demand supply or demand response, reduce carbon emissions, and it reduces electricity theft. It reduces electricity losses in the case of transmission and distribution. Then it reduces electricity cost. It reduces sustained outages and reduces consecutively associated restoration cost. And smart grid is capable of meeting increased consumer demand without adding infrastructure. And comes to disadvantages, present infrastructure is inadequate. It requires high cost of installation. Then smart grid is cyber physical system whose security is complex task. And comes to application, quick recovery after any disturbance in the transmission network. That means if any theft occurs, reduction of generation cost, reduction in peak demands, they improve the adaptiveness of transmission networks. They possess the ability to integrate other renewable energy sources through distributed generations and microgrids. And let us look at some projects by Power Grid in India. Pondicherry Smart Grid Pilot Project, 4 pilot sites, DESCOM project, KEPCO project in Kerala. Hope all you get a brief idea about smart grid. By using smart grid technology, energy can be utilized to the maximum and would not be wasted. This technology also helps to save Earth from the global warming. It refers to modernized version of the earlier traditional method of energy supply. Hope all you got a brief idea about smart grid. Thank you. Think smart. Have a nice day.